Hello and welcome to our fourth video on circles and circle theorems. I'm Mr. Chowdhury and today we're going to be looking at sectors and arc lengths. So before we do anything, your first task will be to try and fill in this table. So if 360 degrees is a full turn, what fraction of a turn are the rest of these degrees? If 360 degrees is a full turn, what fraction of a turn is the rest of these degrees? Pause the video, have a go at that please. Okay, so now let's have a look at the answers to this table. So 180 degrees, well that's half a turn, because if we do 180 out of 360, that's half a turn. 90 degrees is a quarter of a turn, because that's 90 out of 360. A sixth of a turn, 3/4 of a turn, 2/5 of a turn, and then 59 360ths of a turn. So from this table, what are the key points that we can take away? So from the table, what are the key things that we can take away about how to work out what fraction of a turn some degrees are? So let's have a think, right? So the first thing we know is that a full turn is 360 degrees. That's a key thing we need to understand. Because if we know this information, we can then work out what fraction of a turn any degree is. Any amount of a degree, we can work out what fraction of a turn that is. And the way we do that is we do x, which is the value we're looking for, over 360. So a fraction of a turn is x over 360. So for example, for 180, we did 180 over 360. For 270, we did 270 over 360. And that's what we do. And then we can just simplify if we can. So if you have a look at these, the first bunch we could simplify, the last one we can't, so we just left it how it is. Now hopefully that's been pretty straightforward for you and you can do this and find fractions of a turn. If you can't, then I suggest you go and do a bit more practice on simplifying fractions. You can use Corbett Maths or Dr. Frost to help you out with those ones, but we're going to continue with this lesson. So the parts of the circle we need to know and that we need to work with, just as a reminder, that's why I've got this diagram up. We're going to be working with sectors, which is this bit here made by two radii. Radius, we're going to need to know what that is. The circumference, we need to know what that is, and the diameter, we need to know what that is. And one more thing we need to know is what an arc is. So that's an arc there. It's the length or the fraction of the circumference is an arc. So moving on. Similar, linking circles to the starter. We're linking the circles to the starter. What I'd like you to do is pause the video and tell me what fraction of a circle these sectors are. What fraction of a circle these sectors are. Okay, that's all you need to do. Pause the video, have a go at that please. Okay, so here's our answers. It's exactly the same process as before. We're trying to see what these angles are as a fraction of a full turn. So all we need to do is put the degrees of the angle over 360 and then simplify if we can, and that will tell us what fraction of a circle each of these sectors is. Now let's try and apply this to working out the area and the perimeter of sectors, and we're going to need to do some work with arc lengths as well. So here's our first sector. We're given the two lengths as 8 and we're told the angle is 113 degrees. We're given the two lengths and the angle is 113 degrees. So now let's try and work out the area of this sector. So the things that we need to ask ourselves, the main questions we need to ask ourselves are: 1, what information do we have? And then what fraction of a circle do we have? What fraction of a circle are we working with? So now let's answer these questions together. We're going to answer these questions together. So what information do we have? Well, we know that the radius is 8 degrees because we know a sector is split up using two radii. So then we know the radius must be 8 degrees because it's from the center to the circumference of what would be a full circle, but this is just the sector we're working with. The second thing is we know that the fraction of the circle that we're working with is 113 over 360 degrees because our angle is 113 and our full turn is 360. So that's the information we have, and that's the fraction of the circle we are working with. So now we can start working out the area. So that is our full circle in blue there. That's what our full circle would look like. And the area of the full circle would be pi r squared, because that's the formula for working out the area of a circle. We substitute in our values and we get the area of the blue circle, the big blue circle, is 64 pi. The reason I haven't simplified it yet is because we don't want to know the area of the full circle. We want to know the area of the sector. So I'm going to simplify and round right at the end. Okay, so then what we need to do is we need to work out the area of the sector. And we know a sector is a fraction of the circle. So if I know the area of the full circle, if I find out what fraction of the circle I'm working with, I can work out the area of that sector. So what we're going to do is we're going to do the fraction of the circle that we're working with, 113 over 360, and we're going to multiply that by 64 pi, which is the area of the circle. And then we simplify it and round and get our answer as 63.11, and that's to 2 decimal places. And that is how you would work out the area of a sector. Okay, so now that we know how to work out the area of a sector, we need to also be able to work out the perimeter of a sector. Now, the reason I say perimeter and not circumference is because circumference is only applied to circles. A sector, although it is part of a circle or a fraction of a circle, it is not a circle. But you'll see now how we can use our knowledge of circles to help us work out the perimeter of a sector. So once again, we use the same 2 questions. These are the same questions you need to ask yourself every single time, right? And it's not just for areas of sectors and perimeters of sectors. You can use this information on any question you ever asked. You should always ask yourself, what information do we have? That number 1 question applies to everything, but particularly to these types of questions where we're working with sectors. And the second bit, what fraction of a circle do we have? Obviously, this is only specific to sectors and not to all of the types of questions. So now let's answer these questions together. Once again, as you can see, we are given 8 centimeters on the sides of our sector and then 113 as the degrees within our sector. So we know that the radius is 8 centimeters. We know that because it's told us in the question that the radius is 8 centimeters. Now, here's our full circle. Here's our full circle. And if we know the radius is 8, we know that the diameter must be 16 because I've got 2 8s. It's double the radius. The diameter is double the radius. And then the next thing we also know is that the fraction of a circle we're working with is 113 over 360. We cannot simplify that down any further. So now what we need to do is work out the circumference of this circle. The circumference of this circle, because we're going to need that information in a second. So the circumference of the circle is pi times diameter, which means the circumference of the circle in blue would be 16 pi. It's 16 pi. Once again, I'm not simplifying it because I don't want to know the circumference of the circle. I want to know the perimeter of the sector. So I don't need to simplify yet. I'm going to simplify right at the end. Okay, so now we've got this bit. I want to work out this arc length in purple. That's what I need to work out because I don't want the whole circle. I don't want the circumference of the whole circle. I only want that section that we have, that little part of that circle, that arc length within that sector. The curved bit of the sector is the bit that I want. So to work out the arc length, I know the arc length is a fraction of the circumference. The arc length is a fraction of the circumference. I know what fraction of the circle it is, 113 over 360. So I know it's going to be 113 over 360 times 16 pi. That will give me the arc length because that is the fraction of the circle, the fraction of the circumference that I'm looking for. So that gives me this answer. Once again, it looks like a difficult fraction, 452 over 15 pi. It is a difficult fraction, but all of these questions are calculator questions. We can keep these in terms of fraction, in terms of pi, and be very accurate right at the end. So we want to try and keep our accuracy. If this was a non-calculator question, the numbers would be more easy, but for now, this is what you need to concentrate on. Okay, so now that we know that, we need to work out the perimeter of this sector, and the perimeter of the sector would be the 2 radii add the arc length. The 2 radii add the arc length. And the radii are obviously 8 centimeters. We know this from our question. The radii are 8 centimeters, and the arc length we worked out was 452 over 15 pi. Now that we know that, we can pop this into our calculator, get our answer, and simplify it. So the perimeter of our sector is 31.78 to 2 decimal places. The perimeter of our sector is 31.78 to 2 decimal places. Now, here's what I'd like you to do. here is a different question. I want you to have a go at it before we go through it ourselves. So pause the video, have a go. It's fine if you don't get through the whole question. Not an issue. If you get stuck, that's fine. If you get stuck, just unpause the video and carry on watching through my working. So pause the video, have a go at that, please. Okay, so we're going to go through the same kind of process we did in the previous questions. We're going to ask ourselves the same questions again. What information do we have? And what fraction of a circle do we have? So if we look at our shape, the information we're given is that the diameter is 10, which means the radius is going to be 5, because the radius is half of the diameter. And we have 180 degrees, which means we have half a circle. Now that's significantly easier mathematically than the fraction we had earlier. So all we need to do is work out the area of a full circle and then halve it. We just divide it by 2 because this is half a circle. And it's super easy to do this. So we can now do this very quickly. So we know the area of the full circle is pi r squared, which gives us 25 pi. Remember, we don't simplify till right at the end. And then we just take 25 pi and half it, or multiply it by a half, and we get 39.27 to 2 decimal places. Now that's super easy because the fraction of the circle was a half. Now it would still be super easy if the fraction of a circle was a quarter or a sixth or an eighth. It's super easy if we can work out the fraction of the circle. We can just then take the whole circle and then divide it to find the answer. Or multiply it by the fraction to find the answer. It's very straightforward, very simple. So questions like this, where the fractions simplify to a nice, neat little fraction, are significantly easier to the questions we did earlier where they don't simplify. So we know sometimes when the fractions simplify, the questions become super easy. Other times when the questions don't simplify, the questions are a bit more difficult. They require a couple more steps, but in essence the working is exactly the same. So now let's work out the perimeter of this sector. Once again, what do we know? What fraction of a circle is it? So we know the diameter is 10, we know it's half of a circle, so then we can say that the circumference of the full circle is 10 pi. Then we can say that the arc length is half of that, which would be 5 pi, and then we just do the diameter, add the arc length, which gives us 25.71 to 2 decimal places. Now hopefully that's been useful and you'll be able to work that out. Before we go, I'd like you to answer one more question on your own, and I'll go through the answers in a second. So pause the video, have a go at that please. Okay, so let's go through the answers to this one. So this question, the fraction of a circle we're looking at is 350 over 360. I could simplify that to 35 or 36, but I'm just going to leave it like that because that's what I'm going to put into my calculator. So the area of this sector is going to be 350 over 360 multiplied by pi times the radius squared. The radius here is 6 centimeters. So I pop this into my calculator and I get the answer of 109.96, and that's rounded to 2 decimal places. Now the perimeter in purple, the perimeter of this sector is going to be the fraction of the circle, which is 350 over 360 times pi lots of 12, 12 being the diameter, because the radius is 6, the diameter must be 12. Pop that in my calculator and I get 36.65. Now hopefully that's been useful, and before we finish off, we're just going to go over some key points that you need to understand and remember. The first thing that you need to know and understand and remember is that sectors are a fraction of a circle, and they're made up of radii and an arc. Sometimes it could be a diameter and an arc, but it's radii and an arc for most questions. To find the fraction of a circle, we have x over 360, where x is the angle inside of the sector. And lastly, you need to find the area and circumference of a full circle before you find the fraction of the area and perimeter in the sector. So that's what we need to do. We always need to be working with a full circle before we start working with the sector. Once we know the full circle, we can find fractions of that circle to work out the area and perimeter of the sector. Hopefully that's been useful. What I'd like you to do now is go and watch Mr. Amoson's video to do a bit more practice. If you're super confident, go on Dr. Frost, Corbett Maths or MathsWatch to do some extra questions and practice a bit more. Hopefully that's been helpful and you can go off and be productive, and I'll see you in the next video.